Hey everyone, so here we are with our Chapter 2 study guide, and we're going to just start with number 1. Looking at this pattern, we're going to try to see what happens. Alright, well we start at -1 and end up at a +3. And then from a +3, we end up going to a -9. So the pattern I'm seeing is that we're multiplying by -3 each time. So if I get to 27, positive 27, and -3 is what I need to multiply it by, the next term in my pattern would be 81. Okay, moving along, a counterexample. A counterexample proves that something is false. So right here it says B is between A and C. If I were to draw a diagram and have A and C and then put B somewhere between it, it says then A always equals BC. Well, that is not true because look here, B is between it, but AB and BC are not congruent. So you would say a counterexample would be B is not the midpoint. B is not the midpoint. That would make this statement false. False. And then we move up to law of syllogism, or down to law of syllogism, which represents the law of syllogism. Well, it is D, because remember when we had our ballerinas up there, we said if they were equal to each other, these first two, so P and Q are the same, they're the same level of ballerina, and then we say that Q, that one ballerina, is equal to our last ballerina. Well, we just cross off our repeats, we put that one down, and we can say that P is then equal or equivalent to R. And that would be the law of syllogism, D. Okay, number 4. Jennifer sings alto in the choir. The choir voice has 4 parts. The female voice parts are soprano and alto. The male voice parts are tenor and bass. What conjecture can you make? So based on what they told us, what conclusion can we make? Jennifer sings a female voice part in the choir. Yes, this is a possibility. There are no tenor singers in the choir. Well, it doesn't say anything about a tenor, so that isn't a possibility. Alto is the most important voice part in the choir. That says nothing about alto being the most important. And Jennifer will sing 4 voice parts in the choir. Well, we don't know that either. We just know that she sings a female voice part in the choir. So A would be your answer. Okay, number 5. Write in a conditional form. Remember, conditional form is just a fancy way of stating if-then. If a person is a driver, then they are 16 years or over. Okay, identify the hypothesis. Oops, let me move it over here. Or maybe zoom out a sec. Identify the hypothesis. A person is a driver. If you have something along those lines about an individual being a driver, that's fine. A person is a driver. And then the conclusion, they are over 16. Okay, so write the converse. Remember, that's when we flip it. So now I'm going to say, if a person is 16 years or over, if a person is 16 years or over, then they are a driver. Period. Okay. Is that true? If a person is 16 years or over, then they are a driver. That is false. Because even though you might be 16 or older, that doesn't mean that you have your license or that you're driving. Okay, now we have the inverse. Inverse is where you take the original if-then statement and you put a not, or you negate the hypothesis and the conclusion. So I'm going to say, if a person is not a driver, then they are not 16 years or over. Then they are not 16 years or over. So, if you're not a driver, then you're not 16 years or over. Well, again, this is false because there's some people who are not drivers and are 16 years or over. So, that one is false. Write the contrapositive. Okay, that's where we take the converse, and we negate it. So we take if a person is 16 years or over, then they are a driver, and we put nots in front of both of the subjects. If a person is not 16 or over, then they are not a driver. All right. And let's say that that one is true. If you're not over 16, then you're not a driver. Well, at least in this country, if you're not over 16, then you're not going to have your driver's license. Give a counterexample to the converse statement. So the converse, if a person is 16 years or over, then they are a driver. Well, I have a friend, Erica, and she is 34, and she does not drive. Is 34 and does not drive. Booyah. So if you know somebody who's over 16 and doesn't drive, then that could be your counterexample. All right, moving right along. This is the problem where I told you I made an error, and I am so sorry about that. Originally, it was supposed to be minus 45, or not originally, that was how it was supposed to be. But unfortunately, Mrs. Black messed up, and it was not 45. So, I'm going to just solve it this way with the numbers that I have. So I know that the measure of angle 1 is 2x minus 5, and the measure of angle 3 is 4x plus 45. All right, angles 1 and angles 3, those are vertical angles, right? The kissing angles. So I know that they're congruent to each other, which means I'm going to take 2x minus 5 and set it equal to 4x plus 45. I'm going to move my 5 over first, add 5 and add 5, and I will have 2x equals 4x plus 50, and now I'll subtract 4x and subtract 4x and get negative 2x equals 50, and then I'll divide by 2x and I'll get I'll divide by 2 and get x equals negative 25. Okay, it says find the measure of angle 2. Okay, so what I'm going to do is I'm going to plug this negative 25 into angle 1. All right, and then if you notice, angle 1 and 2, they form a straight line. They're a linear pair, and a straight line always equals 180. So once I find angle 1, I'm going to subtract it from 180, and that will give me angle 2. So let's go ahead and plug this in. I am going to do the angle 1 equals 2 times negative 25 minus 5. All right, well 2 times negative 25 is negative 50 minus 5 gives me negative 55. All right, so negative angle 1 equals negative 55. Now, this is where the things stop making sense, because now I need to find angle 2. So I'm going to take angle 1, and I'm going to subtract it from 180. I'm going to subtract negative 55. Well, 2 negative signs here make a positive, so I'm going to add these two together. And that will give me 235 degrees. So the measure of angle 2 equals 235. This is not mathematically sound because this angle couldn't equal 235 as it lies on a straight line, and a straight line is only 180. That's where the problem comes in. But if you got 235, that is fine. Okay, so now I'm going to look down at angle 7. All right, and it tells me that the measure of angle 2 and the measure of angle 3. All right, angle 2 and 3. What do angle, whoops, it's kind of hard to see. Angle 2 and 3 both form. They form a straight line, which is equal to 180 degrees. So I'm going to take this angle, angle 2, 3.7x minus 2.5, add it to 5.8x plus 10.2, and set it equal to 180 degrees. Okie doke. So I'm going to combine like terms. Here's my x's. These are my constants, the number without a variable. And my x's will be 9.5x. And then I will have plus 7.7 equals 180. I'm going to subtract the 7.7 and end up with 9.5x equals 172.3. I'll divide, and I'll get x equals 18.14. All right, now it wants me to find the measure of angle 1. All right, so I know that the measure of angle 1 and angle 3 are congruent because they're vertical angles. So I'm just going to plug it in to angle 3, and that will give me the measure for angle 1. So angle 3 equals 5.8 times 18.14 plus 10.2. Right? When I simplify that, I get 115.41. That's the measure of angle 3, but it's also the measure of angle 1 because they're vertical angles and they're congruent. So the measure of angle 1 equals 115.41 degrees. Okie doke. So now we're going to move down here. This is pretty similar to what you had in the warm-up that one day. So it says if xy equals lm and lm equals pq, then xy equals pq. All right, this is our commonalities. This is like the law of syllogism, but since we're dealing with expressions, we're going to say it's the transitive property. Remember, you skip over what's in common, and then you can say the two are equal to each other. Okay, right here, if the measure of angle A plus the measure of angle B equals 75, and the measure of angle B equals the measure of angle C, so these two are the same, then I can say the measure of angle A plus the measure of angle C, I'm going to use C instead, equals 75. That would be substitution. I'm taking the expression that I have, right, or the equation that I have, and instead of using B, I'm using C instead, substitution. All right, number 10, measure of angle ABC equals the measure of angle ABC. You like to stare at yourself in the mirror. This is the reflexive property. Okay, right here, I've got to get x by itself. I'm going to multiply by 8 and multiply by 8. Multiplication property of equality. Of equality. This is equal. Okay, and then I have AB equals EF. And then it flipped around and EF equals AB. So when it flips, it's symmetric property. And then down here, this 3 was friendly and it went to the x and it went to the -9. That's called the distributive property. And then right here, it says P is the midpoint of SK. Then SP is equal to PK. Well, it's telling you using the word midpoint and then describing a midpoint. So you would say definition excuse me, of a midpoint. Okay, and then down here, it's telling you about a bisector, the word bisect, and then describing what an actual bisector is. Again, definition of an angle bisector. Okay, and here, it's telling you, hey, there's a right angle, and then its measure equals 90. Definition of a right angle. All right, and then down here, hey, perpendicular lines, and they form 4 right angles. Again, definition of perpendicular lines. Angle 1 and 2 are complementary. Then the measure of angle 1 plus the measure of angle 2 equals 90. Again, the word complementary was used, so you would say definition of complementary angles. And number 19. Angles 1 and 2 are supplementary, and angles 1 and 3 are supplementary. So they're both supplementary to the same angle, angle 1, which means it is the congruent supplements theorem. And that's going to be all for the first video. I don't want it to get too long. So number 1 through 19. I will start with 20 in the next video.